Welcome to another Deep Dive, folks. And today we are tackling, I think, a really crucial and fascinating area of AI that's LLM hallucinations.
LLM hallucination.
Yeah, you've given me some really excellent materials on this that go into, like, what they are, why they happen, and what people are doing about it. So I think our goal today is to unpack this complex topic, in a way that's both clear but also engaging. For anyone who's interested in AI, whether they're a tech pro or just, kind of curious about this stuff.
Absolutely.
So this is like your express route to understanding a core challenge in AI right now. We'll, go beyond just the surface and explore, some of the more maybe surprising things and connect the dots so you can walk away feeling really well informed, but not overloaded. You know what I mean?
Yeah.
Like just a good grasp on this. So let's just jump right in. What exactly is an LLM hallucination? Like, how do we even define this thing?
Well, it's really interesting because the term itself, hallucination, is kind of metaphorical, right? It's not like the AI is literally seeing things that aren't there, but it's a way of describing this phenomenon where LLMs generate content that is just plain wrong. It's factually incorrect. It doesn't make sense. It's irrelevant to the input, or it contradicts what we know to be true.
So it's like the AI making stuff up.
Yeah, essentially. And what's key here is it's not a deliberate error. It's not like a programmer made a mistake in the code. It's more a consequence of how these models are designed and how they learn.
Right. So it all comes down to that fundamental way that LLMs work, which is predicting the next word based on patterns in massive data sets, right?
That's exactly it. And that's where things get tricky because while that approach is incredibly powerful for generating human-like text, it doesn't guarantee accuracy. So the AI might spit out something that sounds perfectly plausible, but it's completely detached from reality.
And that's a huge problem, obviously, because we're increasingly relying on these systems for, all sorts of things. And if they're just making stuff up, well, that's kind of scary.
Absolutely. It undermines trust and it poses real risks, especially in areas where accuracy is paramount. Like imagine getting bad medical advice from an AI or relying on legal information that's totally fabricated.
I mean, you don't even have to imagine it, right? We've already seen some pretty troubling real-world examples of this. And it's not just a few isolated incidents either.
Yeah, the prevalence is actually quite significant. Some research suggests that hallucination rates can be as high as 15 to 20% in certain contexts. And some analysts had estimated that chatbots are hallucinating around 27% of the time, with nearly half of their generated text containing factual errors.
27%. That's a lot.
It is. It's a serious issue that we need to address head on.
All right, so now that we've established what LLM hallucinations are and why they're a big deal, let's dig into the different types because the materials you gave me break them down into some really interesting categories.
Yeah, and that's helpful because not all hallucinations are created equal, right? They can manifest in different ways.
So let's walk through them, starting with, I guess, the most straightforward one, factual inaccuracies.
Yeah, those are the ones where the LLM just gets basic facts wrong. Like in one of your sources, there was that example of Thomas Edison invented the internet.
Yeah, classic.
Clearly, the AI is connecting related concepts but missing the factual mark.
Like it knows it's supposed to generate a statement about invention and technology, but it just gets the details totally wrong.
Exactly. Then you have fabricated information, which is even more concerning because this is where the LLM creates entirely fictional content. That ChatGPT example where it falsely accused a professor of sexual misconduct and cited a non-existent report, that's a prime example.
Yeah, that one was really disturbing. To just make up something so specific and potentially damaging.
It highlights the potential for real-world harm. And then there's nonsensical responses where the output might be grammatically correct, but it's just meaningless gibberish.
Word salad.
Basically, it's a sign that the model is struggling with semantic consistency, even if it can produce grammatically sound sentences.
Got it. So what else do we have?
Well, there are contradictions where the AI might present conflicting information either within a single response or across multiple interactions. And then contextual hallucinations where the response is just completely inappropriate or disconnected from the conversation, like mixing up names or suddenly changing the topic.
Like it just lost the thread.
Yeah, exactly. And finally, there's source conflation, where the LLM might incorrectly combine details from different sources or even invent sources altogether.
So it's not just about getting individual facts wrong. It's about creating these elaborate webs of misinformation that could be very convincing, but ultimately totally bogus.
That's the danger. And when you consider the real-world implications, it's pretty alarming. Like that example with the chatbot giving wrong policy advice that cost someone money, or lawyers citing fake legal cases generated by an AI.
Yeah, those are some serious consequences. So where did this all come from? Like, what's at the root of these hallucinations?
Well, a major culprit, as highlighted in your materials, is the training data. The quality of the data that these models learn from has a huge impact on the quality of their output. It's garbage in, garbage out.
Yeah, it makes sense. If you feed an AI a bunch of inaccurate or biased information, it's going to learn those inaccuracies and biases.
Exactly. And one of your sources talks about source reference divergence, which is basically when there are discrepancies between the original source material and how it's represented in the training data.
So even if the original source is accurate, if it gets distorted or misrepresented in the data set, that can lead to problems down the line.
Right. And of course, there's the issue of bias in the training data, which can lead to AI systems that perpetuate harmful stereotypes.
And that's a whole other ethical can of worms that we need to be very careful about.
Absolutely. And even when we use massive data sets, there are limitations. LLMs can hallucinate on topics that weren't well represented in their training data, what's called long-tail knowledge, or on events that happened after their knowledge cutoff date.
So it's like trying to teach a dog new tricks after a certain age. They just can't learn it.
Yeah, kind of, but it's not just about the data itself. The architecture of these LLMs also plays a role in this.
Right, the materials talk about how the transformer model, the dominant architecture for LLMs, relies on predicting the next token based on statistical probabilities. And while that's great for fluency, it doesn't guarantee accuracy.
That's right. It's all about likelihood, not truth. And even those attention mechanisms, which are supposed to help the model understand context, can backfire if the data is noisy or misleading.
So it's paying attention, but to the wrong things.
Exactly. And then there's the issue of model complexity. The more complex the model, the more prone it can be to overfitting.
Which is basically when the model memorizes the training data too well, including all its flaws, and then struggles to generalize to new information.
That's it. And one of your sources even brought up this really fascinating concept of structural hallucinations.
Oh yeah, that was a mind bender.
The suggestion is that there might be inherent limitations in the math and logic behind these models that make perfect accuracy fundamentally unattainable. They even referenced Gödel's incompleteness theorem.
Whoa, okay, so we're getting into some deep philosophical territory here.
It raises the question of whether hallucination is just a bug that we can fix or whether it's a fundamental feature of these systems.
Heavy stuff. So we've talked about data and architecture. Now, what about the decoding strategies? How does the way the LLM generates its response influence the likelihood of hallucinations?
That's another key factor. Your materials highlighted a few strategies like greedy decoding, which basically picks the most likely next word at each step.
But that sounds like it could easily lead down a rabbit hole of nonsense if the model makes an early mistake.
Exactly. It's efficient but can be very error-prone. Then there's beam search, which explores multiple possible sequences of words simultaneously.
So it's like considering multiple paths at once.
Yeah, but even then, it might end up picking the wrong path if the top contenders are all inaccurate. And finally, there are sampling strategies where randomness is introduced into the process.
Like adjusting the temperature parameter to make the model more or less likely to choose unexpected words?
And that can lead to more creative outputs, but also increases the risk of hallucinations. It's all about finding the right balance.
Right. So with all these challenges, what are researchers doing to actually combat these hallucinations?
Thankfully, a lot. Your sources outline some very promising approaches. One is reinforcement learning from human feedback, or RLHF.
Where you basically train the model based on feedback from human evaluators who rate its responses for helpfulness and accuracy.
Exactly. It's like teaching the AI right from wrong through human guidance.
And then there's retrieval augmented generation, or AURAG, which gives the model access to external databases to ground its answers in verified information.
So it's not just relying on its internal knowledge, which might be flawed. It can actually look stuff up in real time.
Like having a superpowered encyclopedia at its fingertips.
And there are fact-checking mechanisms, automated systems that cross-reference the AI's output with trusted sources.
So it's like a fact checker for the AI.
Very meta. And then there's prompt engineering, which is interesting because it's something we as users can control.
Right, by crafting our prompts carefully, we can guide the model towards more reliable answers, like using phrases like, according to this source.
That can make a big difference. And on the data and model side, there's fine-tuning where you train the model on high-quality data sets specific to a particular domain.
So it gets a specialized education on top of its general knowledge.
And your sources also mention some cool architectural solutions like Decoding, which strategically masks parts of the model during decoding to improve accuracy.
And semantic layer integration, which enhances the model with structured knowledge to help it understand concepts better.
It seems like the most effective approach will involve combining multiple strategies.
Yeah, a multi-pronged attack. But the sources were also realistic about the limitations of these techniques, right?
Absolutely. Each one has its own drawbacks and trade-offs, and even measuring the effectiveness of these methods is a challenge in itself.
We need better ways to quantify hallucinations and track progress.
And then there's that nagging question of whether complete elimination is even possible.
Due to those potential fundamental limitations we talked about.
Yeah, it's a sobering thought. But even if we can achieve perfection, the pursuit of significant reductions in hallucination rates is still incredibly important.
So where do we go from here? What are the next steps in this whole LLM hallucination battle?
Research continues on multiple fronts. They're trying to understand model uncertainty, better improve knowledge representation and reasoning capabilities, and develop new architectures that are more robust to hallucinations.
And I imagine we'll see more hybrid approaches, continuous learning systems, and maybe even mixtures of experts where different AI models specialize in different domains.
It's all about creating AI that is not just intelligent, but also reliable and trustworthy.
Because the stakes are high, right?
Incredibly high. The potential for misinformation, harm, and economic loss is huge.
Think about customer service, content creation, education, journalism, law, healthcare. All of these fields could be impacted.
It could erode trust in AI and limit its adoption in critical areas.
So responsible development and deployment are key. We need transparency, safeguards, human oversight, and user education.
To ensure that these powerful technologies are used safely and ethically.
Well, this has been a really fascinating deep dive. I think we've covered a lot of ground today.
We have, from definitions to types, causes, mitigation strategies, and future directions.
And the real-world examples really drive home why this issue is so important.
It's not just a technical challenge, it's a societal one.
And as AI becomes more pervasive in our lives, the need to address LLM hallucinations will only become more urgent.
Absolutely.
So I'll leave our listeners with this question to ponder. How do we balance the incredible potential of LLMs with their inherent tendency to sometimes get things wrong? It's a question that will continue to shape the future of AI, and one that we all need to be thinking about.
I completely agree.
All right, folks, that's all the time we have for today's deep dive.
Thanks for having me.
It's been a pleasure. Make sure to join us again tomorrow at 2 p.m. East African time for another deep dive into the world of AI. And don't forget to subscribe to the Before AGI podcast wherever you get your podcasts. And check out my YouTube channel, Ian Ochin AI, for even more AI content tutorials and insights. See you all tomorrow.